So still focusing on organic chemistry, but now we're on to our second homologous series, which is alkenes. Alkenes are still hydrocarbons, but they no longer have all single bonds. They contain one carbon to carbon double bond that you can see here. Therefore, they are unsaturated, meaning that they don't have the maximum number of single bonds that they possibly could have, because they contain one or more double or triple bonds. So if we just compare this for a second, if we pretend that this is an alkane, that we don't have that double bond, this is what the alkane would look like. We would have two extra hydrogens on there. By getting rid of those two hydrogens from our alkane to form our alkene, we're replacing those two bonds with just one bond, and that's one bond between the two carbons. So we don't have the maximum amount of bonds possible, and that's why it's unsaturated. So the physical properties and the uses. So the properties, alkenes are gases. They are non-polar, the same as alkanes, so there's a very small electronegativity difference between carbon and hydrogen. So they're non-polar, which means they are insoluble in water, because remember, like dissolves in like, and water is polar. There's a big electronegativity difference between the hydrogen and oxygen in the bonds in water. However, they are soluble in non-polar substance, and our example always, if you're asked to give an example of a non-polar solvent at the moment, is always cyclohexane. The uses, alkenes are used to make plastics. For example, ethene is used to make polythene, and ethene is also used to make ethanol for industrial use. So before we name the alkenes, let's first look at the general formula here in red. When we were looking at the alkanes, we had CnH2n plus 2. And so you'll notice the only difference between the blue and the red is this plus 2 here. So I'm just going to show you on this molecule down here on the right. If we were to turn this into an alkane, we would get rid of that double bond and we would add on those extra two hydrogens we spoke about a while ago. However, because we do have the double bond, what we did was we got rid of those two hydrogens and we replaced it with the double bond instead. So it's those two hydrogens that we're taking off our formula here, and so we're left with CnH2n. Now, naming the alkenes is very straightforward. It's the exact same as for the alkanes, with one slight difference. So you start numbering nearest the end with the double bond, and the position of the double bond is indicated like this. So if we were, so on this one for example, it doesn't matter which end you start numbering from. They're both equidistant, the same distance from the double bond. And what we do is this 2 in the formula here. So we know this is butene because it's but for the 4 carbons, and ene because it's an alkene. It has a double bond. And that 2 comes from the fact that when we're counting in from the left, so we go 1, 2, and the double bond starts on that 2. It finishes on the 3, but it's the 2 where it starts from where we're counting that's important. So when we're counting in, our double bond starts on carbon 2, so that's where this 2 comes from in the name. And you'll notice there that it's separated from the letters in the name by these hyphens again, your little dashes there. And then any substituents are named according to the same rules as before. So structural formula of alkenes. We have tetrahedral carbons like we had in all of the alkanes, but this time we have planar carbons too. And I just want to show you that in the 3D model here. So you can see that I've again drawn out my but2ene that we saw on the last slide. I have my 4 carbons and my double bond starts on number 2, and you can see it over on the model. As I flip the model slightly to show you it from a different view, you can see that the carbons on the end are tetrahedral, But in the middle, those two carbons that contain the double bond, they're planar. So I'll just play that just the once for you there, because I don't know how to play it again on this. But you can see that in the middle here, we've got two carbons. You can't see anything sticking up or sticking down from them. The carbons and the hydrogens that are attached to them are all in one plane. So anything that has a double bond, any carbon that has a double bond, is going to be a planar carbon. All of the other carbons that have 4 single bonds, like the 2 on the ends, they are still tetrahedral carbons. So just to write that out for you, tetrahedral carbons are all of the carbon atoms that have 4 single bonds. Planar carbons, so planar compounds have a carbon to carbon or carbon to oxygen, which we'll see later on, double bonds. The atoms in the double bonds are planar. So it's not the whole compound, you still have tetrahedral carbons in the compound, it's the atoms involved in the double bond are planar. So the first example for naming here, hopefully, is straightforward. So we've got 2 carbons, it doesn't matter which side you number them from, they're still 1 and 2. There's no branches, so this must be ethene. Eth because we have 2 carbons, and ene because there's a double bond between them. Next, I've got butene and pentene, and I want you to pause for a second and see if you can name these isomers. So what we're going to do is we are going to number our carbon chains from the side closest to the double bond. So in the first one there, that's going to be numbering from the left. In the second one, we could number from the left or the right, it wouldn't matter. All we have to do here, so we know they're butene, 4 carbons, and there's a double bond in there, so it's butene. We just need to put in the number for where that double bond is. The first one starts on carbon 1, the first double bond, so that's going to be but1ene. We have to go in as far as carbon 2 on the second one for the double bond to start, so that's going to be but2ene. If you didn't make sense of that on your own beforehand, maybe pause now and see if you can name the pentene ones. So the pentene ones, we have to start numbering from the side closest to the double bond. So for both of these, you have to start numbering from the left. I'm trying to get my lefts and right correct. You have to start numbering from the left. I'll just put it in red here. If I was to number the one on the right, from the right, I would end up with my carbon 3 being the one that starts the double bond. Whereas, as always, I want to keep my numbers in my names as low as possible. So it's much better to start from the other side and have it numbered as carbon 2 instead. So that's going to be pent2ene, and the one on the left is going to be pent1ene. So example 3, we're looking at a branched alkene. So if you want to pause this and try to draw it out, and possibly try to name it yourself as well if you can, that would be really good practice. I'm going to go on and do the answer now. So first of all, I can see that I have 1, 2, 3, 4, 5 carbons outside of the brackets. So that means that my main chain is going to have 5 carbons in it. So I'll draw that out first. And I can see it shows me that I've got a double bond between the first 2 over here on the right. So I'll put in my double bond there just to emphasize it a little bit. And then I can go back and put in all my hydrogens. So I'm not going to write the H because, as you can see, my writing is very messy on this. So that's CH3, CH2, CH2, and on the end here I've got CH2. So the reason I'm doing them at the angle there is you don't need to do that. You could draw this straight up and this straight down, and that will be perfect as well. It's just usually we tend to draw them spreading them as far apart as possible, so spreading them away from the double bond. And now the next thing I need to look at is my bracket, and so my bracket is on this carbon here. So what I've got is a CH2 in my bracket, and that means that I've got an ethyl group. So CH2 means that I have 2 carbons coming off of this chain, and I've got 5 hydrogens attached to them. So I fill in my hydrogen like that. So that's the final drawing of it. Obviously I haven't written in all the H's because that'll take forever and it'll be really messy. But we'll try to name that now. So naming it, we need to number it, and you always start from the side closest to the double bond. So we'll start numbering over on the right. 4, 5. So there are my 5 carbons. So I know I have 5 carbons in the chain, so it's going to be pent. I've got a double bond and it starts on carbon 1 here. So it's going to be pent 1 and my ending is ene. It's an alkene. Sorry guys, I got cut off there. So what we had gone as far as was that was pent 1 ene. Hope we're all okay with that. And then naming my side chain. So for that, I'm going to number my carbons in it. I've got 2 carbons, and so that tells me that it's eth, and my ending for a side chain is il. So it's ethyl, and it's on the 2nd carbon in my chain. So that's going to be 2 ethyl pent 1 ene. So for this one, I want you to pause and practice. So pause the video, draw this out for yourself and attempt to name it. So I'm going to put up the answer now. Hopefully you've done this yourself. The answer is that this is 4-ethyl hex 2-ene. So numbering would have started 1, 2, 3, 4, 5, 6. That's my hexene. My double bond starts on carbon 2, so that's why it's hex 2-ene. And on carbon 4 here, I've got an ethyl group. C2H5 means that off that carbon, I've got C2 and 5 hydrogens off of those.